Hi everyone. We're still on straight line graphs, it's pure maths, and this is video number 5. Let's look at this problem here on the board. The problem says that the coordinates of a quadrilateral ABCD are A minus 6, 2, B 4, 8, C 6, 1, and D 9 minus 9, minus 8. Show that the quadrilateral is a trapezium. We all know what a quadrilateral is. It's a figure with 4 sides, and a trapezium has 2 sides that are parallel. In most cases, those are the base sides for a trapezium. The 2 sides are parallel. Quadrilateral could be something like this, even a rectangle. It's a quadrilateral. You see, for a trapezium, it's something like this. If you look at the trapezium, yeah, 2 of the sides are parallel. This one is parallel to this, going in the same direction. The 2 are not, the pair of sides is parallel, the other pair is not. So that's a quadrilateral. Okay? Sorry, that's a trapezium. Trapezium. It's a quadrilateral. This is a quadrilateral, this is a quadrilateral, but this is a trapezium. Quadrilateral is just the big name. There are so many other things that come under it. So this is a trapezium. All right. So what the question says, it says the coordinates of a quadrilateral are this, and that. Show that the quadrilateral is a trapezium. It's like different ways of solving this problem because it's a proof. It says show that it's a proof. Now you have to show that 2 of the sides here are parallel. So either you show it graphically if you want, or you show it analytically. So let's start with the analytic side. So you want to find you have A, B, C, and D, and A is minus 6, 2, B is 4, 8, and C is 6, 1, and D is minus 9, minus 8. You just need to show that 2 sides are parallel. Then you've given the proof. That's all you need to show. So let's look at A and B, whether they are parallel or not. And what do we know about parallel sides? When 2 lines are parallel, because here we're looking at lines, this is straight line graphs, it's line. If 2 lines are parallel, what does that mean to you? If you have a graph like this, let me complete it. Y, X, and you have a line like this, and they say another line is parallel to this one. Say it goes from here to here. So what do you know about these 2 lines? We are not going to prove it. We are just going to state it. When 2 lines are parallel, it means their gradient is the same. We are not going to prove that. If 2 lines are parallel, it means 2 straight lines. If they are parallel, it means that if this was y1 equals x m1 x plus c 1, and this is y. Let me say this is y1, x1. and this is y2, m2, x2 plus c2. If we are told that these two lines are parallel, so it means m1 must be equal to m2. If, on the other hand, because the next problem will involve that, if we are told that these two lines are perpendicular to each other, now this one here is perpendicular to this, they form right angle triangle here, perpendicular. Yeah? So what do we know about their gradients? Their gradient is, the product of their gradient is -1. If two lines are perpendicular, like this, gradients means the product of their gradients, m1, m2, is equals to -1. So these two formula, you need to know them. If they are parallel, their gradients are the same. If they are perpendicular, the product of their gradients is equals to -1. We are not going to prove it. They will never ask you to prove it. You just need to know it. If you want to see how it is proven, you go into the textbooks, you will find it there. So now let's go straight to the problem. Now we are asked to prove, to show that the quadrilateral is a trapezium. So we just need to find two sides that are parallel to each other. Sorry, two sides whose gradients are parallel to each other. So now, A and B, let's look at A and B. A and B. So, when you are writing these coordinates, the first one is your x and the next one is your y. Yeah? So if you want to find the gradients of a line, which is given as m, is always equals to the rise, which is y1 minus y2 if you want, all over the run, which is x, y2 minus y1, all over x2 minus x1. So what this means is the increase in the y-axis over the increase in the x-axis. If you have a graph like this, or a line like this, so you have a point here, let's say this point is A, and this point here is B, and then here you have y, x comma y, x2, x2 comma y2, and here you have x1 comma y1. To find the gradient of this is a point here. This is a number here, see, and this is also the coordinate here. So if you want to find the gradient of this line, this is what you have done here. The gradient m is equals to the increase in y, y2 minus y1, and the increase in x, which is x2 minus x1, is equals to the gradient. So more or less is the rise. This is what you're looking for. This here, this is your rise. This is your y2 minus y1 all over the run. The run, let me just extend this one here. The run is x2 minus x1. So this over this gives you the gradients of your line. So AB. Now for A, it doesn't matter which one you take to be up or down. It doesn't matter as long as you are consistent with the signs. So since here we know B is bigger, so let's say B is now our y2. Our, what am I saying? Yeah. So B y2, which is 8, minus y1, which is minus 2, all over y2, sorry, x2, which is 4, minus x1, which is minus 6. So this gives us 8 minus 2, 6, all over 4 plus 2 now, 4 plus 6 now. So this is 10. So this gives us 3 all over 5. So what is 3 all over 5? Yeah? Now, let's check A, B, C, D. Let's check these two, C and D. Now C, D. Again, let's say this is the bigger one. So you have M here equals to 1 minus 8. So this minus 8 all over 6 minus 9. So this gives us 1 plus 8, which is 9, all over 6 plus 9, which is 15. So what do you get? 3 all over 5. So straight away we have found two lines that are parallel. Now we can conclude without going any further that it is a trapezium because two lines are parallel. We are already told it's a quadrilateral. But now let's take another approach. Let's use the graphical one, which I recommend. Although it's time consuming, but for the purpose of intuition, understanding the problem properly, look at it from a graphical point of view. We have minus 9, minus 8, and 8. So let's say this is our y-axis, this is our x-axis. Y-axis here, x-axis here. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Yes. Y, okay. Minus 2, minus 4, minus 6, minus 8, minus 10. 2, 4, 6, 8, 10. Let me just go 8, 8, 6, 4, 2. This is minus 2, minus 4, minus 6, minus 8, minus 10. This again is minus 2, minus 4 here, minus 6, minus 8, minus 10, 2, 4, 6, 8, 10. So now let's plot what we have here. We have A minus 6, 2, so X is minus 6, X is here, and Y is 2. So where they meet, 2, and so this is our A point here. And we have B 4, 8. X is 4, and Y is 8. So where they meet here, and this is B 4, 8. Yeah, and we have C 6, 1. X is 6, Y is 1. So they meet here, 6, 1. And then D minus 9, minus 8. This is minus 10. So minus 9 is here, minus 8, and minus 8 is here. So let's say they meet here, and this is D, and this is C. So now let's join these points. I'm just trying, since I won't be able to draw a straight line here. This one comes here. This one too goes here. And this goes there. This goes here. So you can see now that this line AB and CD are parallel. This can never be parallel. AD and BC can never be parallel. At some point they will meet, because if you extend them, you keep extending them, keep extending, somewhere they will meet. But these two lines, AB and CD, they will continue to go like this in this straight line to infinity. They will never meet. So this is a trapezium, and AB and CD are parallel. Graphically, this is how you prove it. Thank you for watching. Bye bye.